Good morning, children. Yes, moving to the next chapter, similar triangles. So, in the beginning, let us revise what we already know and then we shall continue with the next part. Similar triangles is a concept which is drawn from similarity of geometrical figures. When do we say that the geometrical figures are similar? First condition is that they should be of same shape, right? That means similar in shape. And the second condition is they need not be of same size, or else we can say that similar shape but of different sizes. So whenever any geometrical figure is of same shape or both are of same shape but are of different sizes, right? Same shape but are of different sizes, then we call them to be similar figures. And now here we are talking about similar triangles. So when we say triangles similar in shape, that means shape should be same. What do you mean by shape should be same? That means corresponding angles of both the triangles must be same. Corresponding angles of the triangles must be same. That is important because shape of the triangle is decided by the angles. So here when we say that same shape or similar shape means same angles. Like in which manner same angles means? Two triangles we say them to be of same angles means corresponding angles must be same. And now when we say the sizes are different means the sides must be proportional in size. Sides of the triangle must be proportional in size. That means ratio of corresponding sides. Ratio of corresponding sides must be constant. Okay, let us try to understand what is meant by these two conditions. Okay, so let's observe. Like there is an object over here. Suppose there is an object over here. Okay, and we are trying to observe the reflection of that object from this mirror from this point. Okay, so observer is here. Right, so you see that means a ray is incident here and it is getting reflected back. You know that angle of incidence is equal to angle of reflection. Therefore, angle made by the ray with the surface is also equal to angle made by the reflected ray with the surface. Of course, reflection we always take with respect to the normal, right? With respect to the normal. If this angle is equal to this means this is also equal to this. So, here you can see that these two angles are equal. Right, these two angles are equal. Now this is the height of the object from the surface. This is the height of the observer, like means where the image is cast, or rather we say that the reflected ray is reaching. So that is the height. So this is making 90 degrees with the surface. This also making 90 degrees with the surface. And now these two angles are also equal. Right? That means see corresponding angles. If you observe, so here at B it is right angle, at E it is right angle. That means A should correspond to D, and of course C, that is A angle ACB corresponds to angle DCE. So that means these angles are equal. That means when you observe the triangle ABC, what do we observe here? Angle A is equal to angle D. Angle B is equal to angle E. Angle ACB is equal to angle DCE. That is angle ACB is equal to angle DCE. That is the meaning of it. That is the meaning of it. That means see now observe this. Shapes are similar. Corresponding angles are equal. Now coming to the size. So when we say speak of size, see this triangle is obviously just by observing you can say that this is bigger than this. That means the size is different. So sizes are different, shapes are same, or rather we say that angles are same, then these two must be similar triangles. But how the size should be? Sizes will be obviously in such a manner that this ratio of the corresponding sides is equal. So that means ratio of corresponding sides. Let me write it as DE. DE corresponds to which one? From this triangle, if it is DE, from this triangle it is AB. So DE by AB, that means height by height, is equal to, right, I can say base CE. CE, which triangle you are taking first in the denominator, that numerator, that only you should take again in the numerator, and the denominator triangle should also not be changed. Now the base of this, so BC. So what is that we observe? Now corresponding heights, right? So therefore what do we say? Height by height, base by base. That means corresponding heights. Let us suppose that h1 by h2 is equal to b1 by b2. Or rather, you can also check this one. h1 by cross multiplication, you will be getting b1 is equal to h2 by b2. Is it not? By cross multiplication you can also write like that. So but the meaning of being proportional means corresponding sides ratio must be constant or must be same. The same other way around you can write it as, see, DE by EC is equal to AB by BC. That means height by base of one triangle is equal to height by base of another triangle. In this manner also you can say. Now suppose if I am taking the hypotenuse here, though it is right angle triangle, therefore I am taking it to be hypotenuse, or else I can say third side. So third side of this triangle DC by third side of this triangle AC is equal to, maybe you can take base by base or you can take height by height. That means first side by first side or second side by second side. This is the meaning of corresponding ratio of corresponding sides is constant. You should understand that meaning first. Then only application will become very easy for you. Okay, this is in case of triangles. What did we learn in our earlier classes? Is it a must that it is only for triangles? No. Any geometrical figure. Just now we discussed that. Geometrical shape. See, here you can see rectangle, set of rectangles, set of triangles, set of concentric circles you can see. So here shapes are same, but sizes are different. Such pictures, such figures, we call them to be similar figures. And now we are moving on to specially what are similar triangles. Now already we have seen the conditions. Again let us revise the conditions and go ahead for the other theorems. Right now take the screenshot of this one so that you can prepare notes. So similar triangles with example. Then this is similar geometrical pictures. Right children, now let us discuss in detail similarity of triangles. Right, see, this is a symbol of similarity. Here we are provided with two triangles, ABC and DEF. So these two triangles, if they are similar, what are the conditions? Then that they are satisfying that corresponding angles are equal. Right, so because it is already given that they are similar, so that means their corresponding angles are equal. So we can conclude that whenever it is given that the two triangles are similar, directly we can conclude this. So conditions, or you can also rather say conclusions also. So when we say that for two triangles to be similar, we talk about that as condition. Now here though it is already given, so you can say that these are conclusions. You can conclude. That means in a particular problem, if two triangles are given to be similar, you can conclude this. What is that? Corresponding angles are equal. What is the meaning of that? Let us write what is the meaning of that. So the first point corresponds to this. So in detail. Now angle A is equal to angle D. So angle A is equal to angle D. Right. What about the other one? This is the corresponding angle to this one. So angle B is equal to angle E. Right. What is the other angle you have? Angle C, which is of course equal to angle F. So then how do we write? Which triangles are similar? Triangle ABC is similar to triangle AEF. By mistake also, you should not write it as AFE. Normally we can write it as a triangle ABC, BCA, CAB, whichever manner you want. But here you are defining that A corresponds to D. DEF. A corresponds to D you are writing. So when you are writing here triangle A, B, C, that means corresponding vertex you have to write D. B corresponds to E. When B comes in the second place, here E should come to the second place. When C corresponds to F, that means A, B, C, D, E, F. These are corresponding triangles. Now suppose if you ask me, ma'am, is this the only way that I have to write? No, you can also write like this. Now suppose if I say triangle CBA, if I say triangle CBA, now I started reading my triangle from here, CBA, right? So in this order, I am going in this order. Then you are supposed to go in this order only. FED. So triangle CBA is similar to triangle FED. So care must be taken in that manner. You cannot just change the names. That means the order in which you are reading your vertices. That is very, very important, children. Please keep that in mind. So corresponding angles are equal. This conclusion you can come to. And now when it comes to corresponding sides are in the same ratio. Now let us discuss about this second point. So corresponding sides. Now AB, right, by DE. Corresponding sides. AB in this one. This corresponds to DE. Right. Is equal to, okay, BC by EF. This is equal to AC by DF. AC by DF. This should be a constant. This should be a constant. See here, I have taken the smaller triangle and the numerator place. So you can also change the whole thing like this. That will make you understand the next point very easily. So I am just reciprocating everything. EF by BC, which is equal to DF by AC. See, I am reciprocating everything here. Suppose if this is equal to this, that means that is going to be 1, is it not? If I equate the whole thing as a constant, because it remains same, right? So once the triangles are constructed, the ratio of the corresponding sides is constant, is the same. So therefore, now suppose if DA by AB is equal to 1, what does it mean? If K is equal to 1, if K is equal to 1, it means that both the triangles are of the same size. We get congruent triangles, right? Implies triangles are congruent. In your earlier classes only you have learned this. Are congruent. When do we say that two triangles are congruent? When they are of similar size and shape also. They are of same size and same shape, then we call them to be congruent. That means if K is equal to 1, triangles become congruent. Suppose if K is greater than 1, that means what is happening? The triangle size is increased. That means your denominator is increased. That means if you take the first triangle as ABC and the second triangle is DEF, then the size of the second triangle is greater than size of the first triangle, is it not? That means you will get an enlarged triangle. What you will get? You will get an enlarged triangle. Right, then next when K is less than 1, so what do we get it? we get a smaller triangle. That means the size reduced in it. So we can say that it is diminished or smaller in size. So we will get diminished triangle. That means the triangle, of course, is going to be similar. So when we say they are congruent, that means here when size and shape both are same, then we say them to be congruent. Hence, whenever we talk about similar triangles, we don't mean it to be congruent. Congruent is another case. We always say that similar triangles means same size and same shape but of different sizes. If they are of same size, then you will directly write it as congruent triangle and we apply the rules of congruency. Okay, children? So just go through the whole thing once again. So here it is given that two triangles are similar. Since it is given to be two triangles to be similar, we are concluding that corresponding angles are equal and the ratio of corresponding sides are same. Or rather we say that the sides are proportional. The sides of the two triangles are proportional. So thus we concluded that we equated it, and also please care should be taken in case of order when you name the triangle ABC, BCA, CAD. Whenever you are ordering the first triangle in a similar order, you have to go with the second triangle whenever you are claiming them or whenever you are saying them to be two to be similar. Okay, so that means when you write the constant of proportionality, then if they are equal, the constant will be 1, and then those triangles are called congruent triangles. If constant is greater than 1, we call them to be enlarged triangle, and if constant is less than 1, we get the diminished triangle. Okay, take a screenshot of it. And then please copy the notes. So now the next part, very most important part here, that is the first theorem of similar triangles, or from this chapter, basic proportionality theorem. So what is the name of the theorem? Basic proportionality theorem, or rather we also call it as Thales theorem. We also call it as Thales theorem. I think you people can see the name here. Right. What does the statement say? If a line is drawn parallel to one side of a triangle. So you imagine in your brain a triangle. And now draw a line parallel to any one side of the triangle in such a manner that that line should touch the other two sides at two different points. Clear? Right. So then he says that the other two sides are divided in the same ratio. So whenever you draw a line parallel to one of the sides of the given triangle, so that it touches the other two sides, then that line is the one which divides the two sides in the same ratio. What is the meaning of it? Let us see that. So now let me say that I took a triangle. So I am taking a triangle here. Okay. So this is what you can also imagine in your brain, A, B, C, if it is a triangle. Now if I draw a line parallel to BC, touching the other two sides, then this is the one which is dividing the triangle sides in equal ratios. That means if I say that this is E and this is D, I can say AE by EB is equal to AD by DC. So that means in equal ratios it is dividing. AE by EB is a ratio. The similar manner it is also dividing the other side, AD by DC. Whenever you draw a line parallel to one of the sides, here we are taking it to be base, and therefore it is how we can explain the statement. Now coming to the proof part. So here what is given for us? Let us suppose that if the triangle is ABC, and if I am drawing a line parallel to, see the arrow marks, this is the meaning that these two are parallel. right? DE is parallel to BC until unless you see this or it is given in the problem, you cannot certain that these are parallel lines. Okay, so now this is parallel to this. This is what which is given to us, and now what we need to prove is AD by DB is equal to AE by EC. That means in which ratio this line is dividing the one side, in the similar ratio it is also dividing the other side. This is what we need to prove, required to prove. And for this we are making some changes or some other additional things in the triangle, like join B and E, D and C, so that you will get a number of triangles in this, and then drop a perpendicular DM onto AE and EN onto AD. So these two are perpendiculars. We are saying that join B and CD and draw perpendiculars D and EN on AE and AD. So these are the basic things, changes that are needed to make to the given triangle in order to prove this one, Okay, now let us see how to proceed. So why are we making these changes? Right, so in order to prove that AD by DB is equal to AE by EC, right? So now, so when you say that this is a perpendicular, that means this is the altitude of this triangle, is it not? You can also say that this is the altitude of this triangle also. You can also say that this is the altitude of the whole triangle. So that means this is going to be the height of, this triangle, this is one triangle, and the other one is, this is the other triangle. That means from this vertex you are dropping an altitude onto this. And that means this becomes the height of the triangle. Which triangle? For which triangles it will become the height? Observe carefully. ADE, this is the height, and AD is the base. Now suppose if I say that ADBE, so this is one. ABE is another triangle if you consider ABE. Then also this is the height. And now I'll say you one more point. If I take this one, okay, that is DBE triangle or BDE triangle, observe what will become the height. This only will become the height. See, you have to extend the base, drop a perpendicular onto the base. That gives you the height of the triangle. It is not necessary that the altitude always lies inside the triangle. Altitudes also lie outside the triangle. So therefore, that means if you are taking this triangle also, please observe this one. If you are taking this triangle also, this becomes the height of the triangle, whereas this is the base of the triangle. This is going to be the base of the triangle. This point if you can understand, the rest everything is very easy. Right, now from triangle ADE and BDE, which triangles you are taking? ADE and BDE. Let me take another pen so that it will be easy for you to understand it. Right, so ADE and BDE, which are the triangles? ADE. That means this triangle I am taking. Children, carefully observe please. I am taking this triangle. For this triangle, this is the base, this is the height. Is that clear? Yes, because this is making 90 degrees here. Okay, so then if I want to find out the area of this triangle, I will write it as half into base into height. Right, so area of triangle AD, ADE, area of triangle ADE, sorry, this is E. Area of triangle ADE is equal to half into EAD is base into EN. EN is the height into EN. Now which is the other triangle you are taking? BDE. This is the other triangle you are taking. This shaded area is another one you are taking. For this also I said, if you extend the base and drop a perpendicular from the opposite vertex, then that will, this is the height and this is the base. Please, this part don't get confused. Don't say that ma'am this is outside the triangle. Yes, altitudes can be outside the triangle. right? So this is how, if you want, I can draw this one like this. See, the triangle is something like this. The triangle is something like this. So now you need to extend the base. Extend the base now. Drop a perpendicular onto this. This becomes the height and this is the base. Please remember, don't take the whole thing as base. So we wanted to find out the height of the triangle, that's all. To find the height of the triangle, you are extending the base. This is what is happening here. So this is the height and this is the base of the triangle. So in case of triangle BDE, right? So this is ADE, ADE and this is BDE. So, and now the half into base into height. Half into base is, what is base? BD, into height is EN. So now just divide these two equations. Just divide these two equations. What will you get? Area of triangle ADB by area of triangle BDE is equal to half and half will get cancelled. EN and EN will get cancelled. So you are left with AD by BD. Let this be equation 1. Let this be equation 1. So we got the first part from the proof. AD by DB or BD. AD by DB. We got AD by DB or BD. Okay, we want the next part now. Now it is very easy for you all now to see. I want AE by EC. That means I want AE by EC. Which triangle am I going to take? I am going to take this triangle again, AED. And the other one is going to be this one, CED or ECD or DCE. This triangle I am going to take. So these two triangles I am going to. For this triangle, if I am taking this as the base, because I want AE here, I want this as the base, then this becomes the height, DM becomes the height. And for this triangle again, if you extend the base, this becomes the height. Okay, children? So now let me shade this one with some other different color so that you can easily identify what is the other triangle you are taking. This is the other triangle you are taking. That is CDE. Right? So I am taking triangle ADE again. ADE. In which I am taking this as the base. If I take this as the base, this will become the height. So area of the triangle is half base into height, that is AE into DM. I am taking this triangle now. In this triangle, this is the base and this is the height. So half into base is EC into DM. So what is our next step? Just divide these two equations. You can see that half and half will get cancelled. DM and DM will get cancelled. We are left with AE by EC. AE by EC. This is the second equation. This is the second equation. Now please see, observe. This is already ADE, same. Triangle ADE, ADE. Now observe, you have on the same common base, with the same height. Right, these two triangles are equal. That means this is of the same height. With the same height, you have two triangles with the same base on the same common base. That means area of triangle BDE is equal to area of triangle CDE. That means this ratio is equal to this ratio. Is it not? That means 1 is equal to 2. Therefore, equation 1 is equal to equation 2, which implies AD by BD is equal to AD by BD is equal to AD by BD is equal to AE by EC. Hence proved. Okay, children. So this is all what you have to do, and you have to write that one. Why these two areas are equal? That means with having the same common base, and you can see that the same common heights over here, because they have the same heights from the same triangle with the same area. Okay, thus these two areas are equal. Hence, when these two areas are equal, you can equate this ratio to this ratio, and this ratio is giving you AD by BD. This ratio is giving you by AE by EC. Thus, hence proved. Okay, children, take a screenshot so that you can copy the notes. The statement part first. It is also called as Thales theorem. So that means whenever you are drawing a line parallel to one of the sides of the triangle, in a manner that it touches the other two sides at two different points, then that line divides the sides in such a manner that the ratio of division of both the sides is same. Okay, so this is the screenshot. Take the screenshot, and this is the diagram part. Try to understand why we are taking the external drawn latitude as the height, and this is the conclusion part. Okay, children? Yes.